Today, it's our pleasure to present to you the show Into the Quantum Realm, the Future of Computing. Technology giants and countries are locked in a race to achieve quantum supremacy, which means to build a quantum computer that outperforms the best classical computers in specific important tasks. Why are these companies and governments investing so much money and resources in the hope of being the first to achieve this milestone? Buckle up, we are about to delve into the fascinating world of quantum computers. They are totally different from today's computers. Quantum computers harness the principles of quantum mechanics to tackle problems that even the most powerful supercomputers cannot solve. Imagine finding a specific grain of sand on a vast beach in seconds instead of years. That's the power of the quantum advantage. Governments aren't just racing to build them for bragging rights. Being the first to succeed will bring an enormous competitive advantage in the global economy. So, get ready to explore a whole new world of computers. To truly grasp the intricacies of quantum computers, we must first dive into the fascinating and often counterintuitive realm of quantum mechanics. Quantum mechanics studies the behavior of tiny particles like photons, the fundamental units of light, and the components of atoms, notably electrons, known primarily for their role in electricity generation. To grasp the incredible scale of these particles, consider this. There are billions of electrons in the tip of a needle. That's how small they are. Particles of such incredibly small size behave very differently from the larger objects we encounter in everyday life. So comprehending their actions requires a completely new set of rules, which scientists have been studying for about a century. According to quantum mechanics, these extremely small objects can behave as both particles, as commonly understood, and as waves, exhibiting properties and behavior similar to waves in the ocean, light, or sound. Known as wave-particle duality, this theory is a cornerstone of modern physics, essential for explaining various quantum phenomena that can't be explained using classical physics principles established over several centuries by scientists such as Isaac Newton. Unlike classical computers that use zeros and ones, or bits, to process information, quantum mechanics use quantum bits, or qubits. Unlike bits, qubits can exist in what is called a superposition of both 0 and 1 at the same time, like a coin spinning in the air, neither head nor tail, but both possibilities in motion until it settles. However, when measured or observed, only one of the superposed states becomes observable. This allows for exploration of multiple solutions simultaneously. But the peculiarity doesn't stop there. A phenomenon known as entanglement connects particles or qubits in a bizarre way. When two qubits become entangled, their destinies become intertwined. Dr. Albert Einstein famously referred to this phenomenon as spooky action at a distance. Measuring one entangled qubit immediately affects the other, no matter how far away they are. Imagine two coins, magically linked across the globe. Flip one and the other instantly flips in the opposite direction. This mind-bending connection that transcends space and time is the essence of quantum entanglement. Sounds quirky, right? Rest assured, we will provide a simplified example to make quantum computing easier to understand. Imagine finding yourself trapped in an intricate, sprawling maze. Traditionally, you would scurry through every twist and turn, a slow and tedious journey of trial and error to reach the exit. But what if there were a way to explore all possible paths simultaneously, causing the maze's complexity to collapse in an instant? That's the amazing promise of quantum computing. Think of each path in the maze representing a qubit. According to the principle of superposition, qubits can simultaneously exist in multiple states, such as up and down, or left and right, exploring every possible direction within the maze at the same time. and entanglement connects the qubits like an invisible thread. When you choose a direction for the qubit at the entrance, its entangled partner at the exit instantly flips to its opposite state, effectively erasing all incorrect paths or wrong turns and collapsing the maze instantly. This is essentially how quantum computers work. Increasing the number of entangled qubits vastly expands the simultaneous exploration of paths, much like unfolding a map guided by the invisible connections. This is the essence of quantum computing's power, the capability to solve complex problems by exploring all potential solutions at the same time, something classical computers cannot achieve. Quantum computers, through harnessing the bizarre laws of the quantum world, have the potential to revolutionize various fields. Just imagine designing aircraft with lighter, stronger alloys that push the boundaries of efficiency, ultimately reducing the cost of air travel and freight. Picture solar cells with unprecedented conversion rates, capturing more of the sun's energy from the same space. Quantum computers could even be used to create personalized medicines tailored to your unique genetic code, with drugs designed for pinpoint accuracy. These are just a few of the possibilities unlocked by the unique ability of quantum computers to simulate complex materials and biological processes with unparalleled precision. Beyond the physical realm, quantum computers could also transform the worlds of finance and artificial intelligence. Their ability to analyze vast amounts of data in intricate ways could pave the way for sophisticated financial models and advancements in machine learning, mimicking the learning process of the human brain. Now, let's see what a quantum computer looks like. Quantum computers look more like something out of a science fiction movie. There are several ways to build a quantum computer, but let's explore one leading example, which resembles a futuristic chandelier.
In the computer lab, they are now installing a chip that uses a different kind of superposition, using superconducting circuits, but which works in a similar way. The computer has several levels of shielding and is cooled down to nearly absolute zero so that the quantum state won't be disturbed by heat radiation. The chip is connected to microwave lines that can both check and control the quantum information of each individual bit. And this is necessary.
This futuristic chandelier-like device shows us the potential of quantum computers to achieve seemingly impossible feats. However, quantum computers also face challenges related to noise control, error correction, and scalability. There are also serious security implications. This quantum power comes with a price: fragility. Qubits are extremely sensitive, and errors can be easily caused by heat, noise, and other disturbances, which can cause the qubits to lose their superposition, leading to computational errors. So, they need to be kept in extremely cold refrigerators, at temperatures near absolute zero. That's even colder than outer space. Dr. Michio Kaku is a professor of physics at the City University of New York in the USA. He is a renowned physicist, futurist, and popular science communicator. Professor Kaku insightfully explains that maintaining the coherence of qubits is a major challenge for scientists, and we should learn from Mother Nature. Mother Nature can create coherence at room temperature.
Digital computers compute on zeros and ones, zeros and ones, zeros and ones. How can that describe a molecule? You can't. That's why we need a quantum computer to break through that. We're dealing with atoms now, and atoms vibrate. Noise can affect the calculation. That's why a quantum computer, what do they look like? They look like a chandelier. The chandelier are pipes that control liquid helium. And it's the pipes that cool the quantum computer down to near absolute zero. And that's what you need to do a calculation. Mother Nature does quantum calculations at room temperature. What do we call that? We call those flowers, leaves, forests. These are all quantum mechanical. The way in which a flower can capture a photon of light, combine it with carbon dioxide to make sugar, that's a quantum process. And we cannot duplicate that without bringing everything down to near absolute zero. So we got a ways to go to catch up. In other words, the ultimate quantum computer is Mother Nature. Mother Nature is still ahead of us. Mother Nature is a master of quantum computation.
While quantum computers may provide us with a powerful new tool to enhance our comprehension of the workings of nature, developers and policymakers should prioritize minimizing the environmental impact and ensuring long-term sustainability. Our beloved Supreme Master Ching Hai, vegan, has enlightened us about the consequences when heavily relying on advanced technology development and has imparted wisdom regarding its use.
There's at least one planet, another planet, not this planet, that developed super intelligent AI, and later on, they regretted it because these AI formed together like a big army, and then they demanded that they be treated like other beings of theirs. In the beginning, humans there were very happy, and then have them do many things. But later, these AI rebelled. They revolted. They have a plan, and they destroy all this AI that they so much loved, but became a danger to them.
Right.
Our planet could face this kind of dilemma if we're not careful enough. Because sometimes the scientists overdo things. They just zoom in their work and they don't consider how the outcome could make trouble. If it goes together with the development, then it's easier to control. But if people just develop like AI and without any source of moral and limit control of the actions, of the consequences, then it could be not very safe.
Yes.
Yes. So wisdom has to go with love also, yes, and moral. Otherwise, it could be dangerous.
Enlightened viewers, thank you for being vegan and making a positive impact in the world. It has been a pleasure having your company today during our show, Into the Quantum Realm, the Future of Computing.